October 30th, 1941, Wright Field, Ohio. As war consumed Europe and threatened to engulf the Pacific, American military planners gathered around conference tables with a troubling question that kept them awake at night. What happens when the aluminum runs out? German submarines prowled the Atlantic, threatening supply lines that brought bauxite ore from South American mines to American smelters. Japanese forces eyed the Dutch East Indies, home to critical mineral resources. The mathematics were brutal and unavoidable. Each fighter aircraft consumed approximately 1 ton of aluminum. Each bomber required 3 to 5 tons. American war planners projected needing 50,000 aircraft, perhaps more. The numbers simply didn't add up. In that autumn meeting, Bell Aircraft representatives proposed something that seemed either brilliant or desperate, depending on who was listening. Build fighters from wood. Not as a compromise, but as a complete reimagining of what a fighter could be. Use America's forests instead of her mines. Tap into 18 billion board feet of standing timber inventory, with capacity to produce 36 billion more annually. Create an aircraft so light, so simple, so cheap that it could be mass-produced in furniture factories and piano shops across the nation. The concept wasn't entirely new. It had roots stretching back to the glamorous days before the war, when speed was measured in trophies instead of kill ratios. The dream began not with military necessity, but with publicity and ego. In 1935, weeks after founding Bell Aircraft Corporation, Larry Bell called his chief engineer Bob Woods into his office with an idea that had nothing to do with war. Bell wanted to enter the Cleveland National Air Races, specifically the Thompson Trophy race, where sleek, purpose-built racers screamed around pylons at speeds that made production aircraft look like they were standing still. Woods, who knew more about military contracts than air racing, sketched a concept anyway. A lightweight wooden racer, minimalist and pure, built for speed above all else. It would be small, agile, constructed from readily available materials. The racer never competed. The design sat in filing cabinets, while Bell pursued more lucrative military contracts. But the concept remained, waiting for the right moment to emerge from obscurity. That moment came in October 1941, 2 months before Pearl Harbor would transform American society forever. The Army wanted what they called the 4-4-4 combination: 400 horsepower, 4,000 pounds, 400 miles per hour. A lightweight interceptor that could defend against enemy bombers while consuming minimal strategic materials. Woods pulled out those old racing sketches and adapted them for military purpose. The proposal landed on Army desks with specifications that seemed too good to be true. An aircraft weighing under 3,750 pounds empty, nearly 1,000 pounds lighter than a Japanese Zero. Wooden construction throughout using ribbing, nails, glue and resin-bonded skin covered in cotton fabric. A slim Ranger V770 engine producing 520 horsepower. Armament consisting of one 20mm cannon firing through the propeller hub and 2 50 caliber machine guns. Projected top speed of 410 miles per hour at 27,000 feet with the promised supercharged engine. The Army, desperate for alternatives to aluminum-dependent production, ordered 25 aircraft on May 16, 1942. The XP-77 designation made it official. America would build a wooden fighter. The design featured distinctive characteristics that marked it as uniquely Bell. The long slender nose housed the inverted V-12 engine and cannon. The fuselage cross-section formed a triangle, typical of Bell's design philosophy. Tricycle landing gear, another Bell trademark, promised excellent ground handling. Most unusually, the cockpit sat so far aft that pilots could actually see the main landing gear extended beneath the wings. Only the nose gear required an indicator light. This rearward position would later prove problematic in ways designers hadn't anticipated. The technical approach seemed sound on paper. Sitka spruce, the same wood that built training aircraft and even some British combat planes, formed the primary structure. Plywood sheets created the skin. Resin bonding promised strength equivalent to metal in many applications. The fabric covering, properly treated, would be weather-resistant and reasonably durable. Furniture manufacturers across America possessed the skills and equipment to build such aircraft. Piano factories with their expertise in precision woodworking could contribute. The vision extended beyond one aircraft type to an entire shadow industry, producing fighters without touching the aluminum supply. Reality began diverging from vision almost immediately. weight crept upward from the first calculations. The engine that would make the performance possible, the supercharged Ranger 15th 779, existed only on paper. Ranger Aircraft Engine Division, struggling with development problems, couldn't deliver. They offered instead the 15777, a non-supercharged variant producing the same 520 horsepower at sea level, but losing power dramatically above 12,000 feet. The promised high-altitude performance vanished. Bell faced an impossible choice: wait 18 months for an engine that might never materialize, or proceed with an inadequate power plant. September 1942 brought the mock-up inspection. Army representatives and Bell engineers gathered around the full-scale wooden model, and the problems multiplied with each measurement. Weight had exceeded 3,700 pounds, approaching 4,000. The 56-gallon fuel capacity, barely adequate in the original design, now meant desperately short range. Internal volume for ammunition had shrunk. The proposed armament of one 20mm cannon and two 50-caliber machine guns would carry only 200 rounds per gun. Combat aircraft typically carried at least 3 times that amount. A fighter that expended its ammunition in seconds of firing had limited tactical value. The Army reduced its order from 25 to 6 aircraft. Then, as costs mounted and delays extended, to just 2 prototypes. The project continued not because anyone believed the XP-77 would become a frontline fighter, but because evaluating wooden construction techniques might prove valuable. Meanwhile, the war situation that spawned the project was transforming in ways that made the XP-77 increasingly irrelevant. Aluminum hadn't become scarce. American production expanded dramatically. In 1941, the United States produced 280,000 tons of aluminum. By 1944, production reached 1.25 million tons annually. The feared shortage never materialized. Simultaneously, American fighter doctrine evolved beyond simple interception. The Lockheed P-38 Lightning, Republic P-47 Thunderbolt, and North American P-51 Mustang proved that fighters could escort bombers across Germany, strafe ground targets, carry bombs, and still dominate air combat. The Army wanted versatile aircraft, not specialized interceptors. The XP-77, designed for a narrow mission using materials that were no longer critical, had lost its purpose before the first prototype flew. Construction delays mounted like compounding interest on a bad debt. Bell had subcontracted the wooden construction to specialized firms because their own factories were overwhelmed with P-39 Airacobra and P-63 King Cobra production. The original subcontractor, after beginning work, refused to release necessary parts when the contract shifted. A second subcontractor had to start from scratch. Concerns about glue emerged. Would the bonding hold under combat stress? Temperature extremes? Humidity changes? Wood from different sources had different properties. Quality control that was straightforward with aluminum alloys became complex with organic materials. Each piece of wood had unique grain patterns, density variations, moisture content. Standardization proved elusive. April 1st, 1944. Nearly 2 years after the original order, the first XP-77 lifted off from Wright Field, with test pilot Jack Woolhams at the controls. The 25-minute flight revealed an aircraft that fell short of every promise. Top speed reached 329 miles per hour, 81 miles per hour below the projected 410. The aircraft vibrated excessively at certain speeds because the Ranger V770 engine mounted rigidly to the airframe without vibration isolation. Designers had eliminated rubber mounts to save weight, creating a direct transmission path for engine vibrations into the structure and cockpit. Pilots reported the cockpit was cramped, noisy, and unpleasant. Forward visibility was restricted by the long nose. The rearward cockpit position that seemed clever in mock-up form proved problematic in flight. Pilots couldn't see what lay ahead and below, a critical blind spot during landing and ground attack. The takeoff distance stretched far longer than conventional fighters. Climb rate disappointed. The Army had expected an interceptor that could reach altitude quickly. Instead, the XP-77 climbed slower than the fighters already in service. May 2nd brought disaster. During testing at Wright Field, the nose gear collapsed during a hard landing. The aircraft skidded along the runway, damaging the wooden structure. Repairs consumed 11 weeks, precious time that allowed conventional fighters to prove themselves in combat, while the XP-77 sat in a hangar being rebuilt. By July 22nd, repairs were complete. Both prototypes were ferried to Eglin Field in Florida for operational testing. The evaluation that followed was damning in its thoroughness. Handling characteristics were good, testers admitted. The tricycle gear provided stable ground handling, controls responded adequately. But performance remained subpar across every metric that mattered. Speed was notably slower than conventional fighters. Climb rate was inadequate for interception duties. Range was limited by the small fuel capacity. The restricted ammunition load meant brief combat capability. The Air Force conclusion was brutally direct. The XP-77 would have no appreciable advantage in speed, climb, maneuverability, or firepower over existing production fighters. To gain any advantage from its lightweight, the aircraft would need to weigh just 3,000 pounds, which would require eliminating fuel and ammunition capacity even further. A fighter without fuel or bullets has no military value. October 2nd, 1944. The second prototype lifted off from Eglin Field for what would be its final flight. The pilot attempted an Immelmann turn, a maneuver that should have been routine for a fighter aircraft. Instead, the XP-77 entered an inverted spin. The pilot, recognizing that recovery was impossible, bailed out safely. The aircraft crashed and was destroyed. Investigators suspected the Rangerfly 770 engine, which had demonstrated reliability issues throughout testing. The loss of the second prototype accelerated the inevitable. December 2nd, 1944. The Army Air Forces officially terminated the XP-77 program. 2 years and significant funding had produced one flyable aircraft with performance inferior to fighters already in mass production. The official documents cited multiple reasons: inadequate performance across all categories, technical problems including excessive vibration and structural concerns. Disappearance of the original justification as aluminum remained abundant, shifting tactical requirements toward multi-role fighters. But perhaps most ironic was a fact that emerged only after the war ended. The lumber shortage that never threatened aluminum production had nearly materialized anyway. America's vast forests had seemed inexhaustible in 1941 when the XP-77 was proposed. Those 18 billion board feet of lumber stocks appeared more than adequate. By 1945, reality told a different story. Total lumber stocks had collapsed to 4.5 billion board feet, a 75% reduction. These remaining stocks consisted mostly of pipeline inventory and broken assortments of sizes and grades. The high-quality boards needed for aircraft construction had become scarce. Aircraft-quality spruce was particularly difficult to obtain. The furniture factories and piano shops that were supposed to build wooden fighters were themselves struggling to obtain materials. Plywood production couldn't keep pace with demand. The assumption that wood represented an inexhaustible strategic reserve proved as flawed as the assumption that aluminum would become scarce. Both materials faced constraints. Both required careful management. The supposed advantage of wooden construction was illusory. If the XP-77 had entered production, it would have competed with other wooden aircraft, training planes, gliders, crates for shipping supplies, construction lumber for bases and housing, and countless other military needs. The shadow industry that would build fighters in furniture factories would have diverted capacity from other essential production. In the end, the aluminum-based conventional fighters proved to be the correct choice. Mass production of P-38 Lightnings, P-47 Thunderbolts, and P-51 Mustangs gave America air superiority. These aircraft used aluminum, but American industry expanded production to meet demand. The first XP-77, the sole survivor, began a long journey through obscurity. After program cancellation, it was sent to Wilbur Wright Field, then to Eglin Field, then back to Wright. For years it appeared at various air shows, a curiosity that attracted attention for its unusual design and failed promise. Then it served time as a gate guard at an unknown airbase, slowly deteriorating under sun and rain. Wood, unlike aluminum, doesn't age gracefully outdoors. Eventually someone decided the deteriorated aircraft wasn't worth preserving. It was burned, destroyed by the very material that was supposed to be its advantage. For decades, historians assumed no XP-77 survived. The program had been a failure, the aircraft destroyed, the concept abandoned. But in the 1970s, researchers discovered the truth. The aircraft that had been burned was not the XP-77, but a different wooden aircraft mistakenly identified. The first prototype had survived after all. Today it resides at the National Museum of the United States Air Force in Dayton, Ohio. Visitors can see this peculiar aircraft with its long nose, triangular fuselage, and rearward cockpit. They can read the specification plaques listing the disappointing performance figures. They can understand why this wooden fighter never saw combat. The Bell XP-77 represents more than a failed aircraft program. It embodies the fog of uncertainty that pervades wartime planning. In October 1941, when Bell proposed building fighters from wood, American planners faced genuine unknowns. Would aluminum become scarce? Would conventional production meet demand? Could alternative materials provide equivalent performance? The decision to pursue the XP-77 made sense given the information available. The decision to cancel it made sense given what was later learned. The program cost money and time but provided valuable data. Engineers learned that wooden aircraft construction, while feasible for trainers and light aircraft, couldn't match metal construction for high-performance fighters. The weight savings were offset by structural limitations. The supposed ease of production was complicated by quality control issues. The abundance of raw materials was less secure than assumed. These lessons informed future decisions. When the Air Force needed aircraft in later years, they never again seriously considered wooden fighters. The XP-77 also reminds us that military aviation advanced rapidly during World War II. An aircraft designed in 1941 was obsolete by 1944. The performance that seemed adequate at the beginning of the war was laughable by the end. Speed increased from 300 miles per hour to over 400. Range doubled. Firepower multiplied. Reliability improved dramatically. Any aircraft that spent 3 years in development emerged into a completely transformed environment. The wooden fighter sits in Dayton today as testament to paths not taken, to reasonable ideas that didn't work, to the difference between theory and practice. Its long nose points toward nothing. Its guns never fired in anger. Its propeller never pulled it into combat. The Bell XP-77 was America's emergency fighter built from wood, created to solve a problem that never materialized, built with materials that became nearly as scarce as those it was meant to replace, rendered obsolete before completion by the very industrial capacity it was designed to supplement. Sometimes the greatest lessons come not from successes but from failures, not from what we built but from what we learned we shouldn't build. The wooden fighter taught American aviation that some shortcuts lead nowhere, that some alternatives cost more than the original, that sometimes the conventional approach succeeds because it works. The forests that were supposed to build America's defense remained forests. The aluminum that was supposed to run short kept flowing from expanded smelters. The fighters that were supposed to be impossible were built by the tens of thousands. And one peculiar wooden prototype sits in a museum, preserved not as a triumph, but as a reminder that even failed experiments contribute to knowledge, that even cancelled programs serve a purpose, that even the aircraft that never fought still has a story worth remembering about the desperate calculations of nations at war.